Hello guys, welcome to another video here on Intro to SSRF. This means the Server-Side Request Forgery vulnerability. This is under the Web Fundamentals learning part on Tryhackme, and we're currently on the Introduction to Web Hacking, Room 7, which is the SSRF. Without further ado, let's jump into it. In this room, we are going to learn how to exploit server-side request forgery vulnerabilities and allowing also you to access internal server resources. Task 1. What is SSRF? Room brief. In this room, you will learn what an SSRF is, what kind of impact they can have. You'll view some example of SSRF attacks, and then how you can discover SSRF vulnerabilities, how to circumvent impute rules, and then we can have a practice for you against which to try your newfound skill. What is SSRF? SSRF stands for Server-Side Request Forgery. It is a vulnerability that allows a malicious user to cause the web server to make an additional or edited HTTP request to the resource of the attacker's choosing. Now, the type of SSRFs that we have, there are two types of SSRF vulnerabilities. The first is a regular SSRF. This is where data is returned to the attacker's screen. And the second is a blind SSRF vulnerability, where an SSRF occurs but no information is returned to the attacker's screen. Now, what is the impact, or what impacts can SSRF have? A successful SSRF attack can result in any of the following. It could result to access to unauthorized areas. It could result to access to customer or organizational data. It could result to ability to scale to internal networks, and it could also lead to revealing authentication tokens or credential. Now let's quickly answer some questions here. What does SSRF stand for? It is server-side, there's an hyphen, a dash, server-side request forgery. Okay, forgery. Submit, and that's correct. As opposed to a regular SSRF, what is the other type? So we have regular and blind, where we don't have results or returned to the attacker screen. So blind, hit submit, and that's correct. Let's head on to task 2. Click the view site button, which will take you through some common SSRF examples, how to exploit them, and even a simulation to see if you can take advantage of an SSRF vulnerability using what you've learned. So let's click on view site and let's quickly read this. Now, instructions. We are going to take you through some sample SSRF attacks and explain how they work. At the end of the examples, you will have to figure one out for yourself. That's okay. Next. The below example shows how the attacker can have complete control over the page requested to the web server. Now, the expected request is what the website.thm server is expecting to receive. Okay. Now, with the selection in red being the URL that the website will fetch for the information, the attacker can modify the area in red to an URL of their choice. Okay. Now, the expected request in this example here is, if you watch the additional URL http://api.website.thm wants to pick the stock information of an item ID is 123. Now you see that number one, what the hacker does is the hacker requests that same URL but changes to the URL of his choice. This time he wants information on the user. So he wants the user data. So after the api.website.thm, you can see that /API/user instead of the /stock/item ID equals to 123. Now, step 2, the website request. Now, the website now requests for that particular URL that the hacker imputed instead of the expected request. And now the third is the API server. API server now returns user data to the website instead of the stock information. And lastly, the website will now return that user data to the hacker's screen. Next, we find out that the below example shows how an attacker can still reach the API/user page with only having control over the path by utilizing directory traversal. When a website.thm receives ... this is a message to move up a directory which removes the /stock portion of the request and returns the final request into API user. If you remember our last video on file inclusion, we treated more on directory traversal or path traversal. So it's more or less moving up one step the directory location. Now, on this expected request, we needed the URL to get us an item in the item / or the query string ID equals to 123. But if you watch the hacker's request, he included the URL now to be / then user using the directory traversal. Now, the website request, instead of now using the going to get the item ID or the stock information, it now goes up one directory above and goes into the user information directory. And then the API server returns the user data to the website instead of stock information. And number 4, we have the website return the user data to the hacker. Okay, that's that for the example. Example 3. In this example, the attacker can control the server subdomain to which the request is made. Okay, and take note of the payload ending in &x equals to being used to stop the remaining part from being appended to the end of the attacker's URL, and instead turns it into a parameter, which is a query string x equals to on the query string, right? And the expected request here says server equals to the API, then and ID equals to 123. But the request from the hacker now has the API.website.thm, a different domain here, or a different subdomain here, with API assessing for user. And x equals to, this would basically is appended to the end of the attacker's URL, and instead of it to generate whatever comes after it, it turns it into a parameter on the query string. Hence, the website request would only go in to get the user information, and the API server would return that user data to website instead of stock information. And lastly, the website will return the user data to the hacker. Okay, read next, and I think this is the last example. Going back to the original request, the attacker can instead force the web server to request a server of the attacker's choice. Okay, by doing so, we can capture request headers that are sent to the attacker's specific domain. Now, these headers can or could contain authentication credentials or API keys sent by the website.thm. That would normally authenticate to api.website.thm. So in this example now, we see the request here is that the hacker is using an appended domain here, which would redirect to get us or capture request headers. Hence, it will not go through the normal website request and the API server returning information. Rather, these headers could just directly be sent to the hacker, whereby the website will now get the information from hackerdomain.thm instead of api.website.thm, revealing the API key. Next here is, I think this is the one we need to figure out ourselves. It says, using what you've learned, try changing the address in the browser below to force the web server to return data from the https server.website.thm flag ID equals to 9. To make things easier, the server requesting bar at the bottom of the mock browser will show you the URL that the website.thm is requesting. So as you can see, we have the website here. At this point, it has an item 2 where server equals to API. So if we hit enter here, you'll see that it said item 2 found. Now, for us to be able to utilize this SSRF vulnerability on this particular URL, we'll just take out API. I'm going to copy from server here equals server.website.thm where flag ID equals to 9. Copy that URL and append it to this point. If I hit enter, I'll get an error, 404 not found. And to do this, or to get a better result, I think I might just use the trick where we have and x equals to, and see what happens. And there we go. We have our flag. Okay, we have a flag, and we'll copy that, paste that. Let's see the hint previously. Append and x equals to at the end to ignore the rest of the URL. Okay, we submit, and that answers task 2. So let's minimize and let's head on to task 3. Okay, now finding an SSRF. Potential SSRF vulnerabilities can be spotted in web applications in many different ways. Here is an example of 4 common places to look. Number 1, when a full URL is used in a parameter in the address bar, you can see a full URL with http://. It has the protocol, it has the domain name, it has the parameters. Okay, so when we spot this, it's a possible vulnerability for SSRF. Now, number 2 is a hidden field in a form. So when you open the source code of a file and you're able to see where we can see something like name equals to server with a value, having a hidden form here, it's a possible vulnerability on SSRF, or a possible SSRF vulnerability. The third example is a partial URL such as just the host name. So a situation where we have a server equals to API, where we can see it's the host name. So basically this could be a potential SSRF vulnerability. And lastly, or perhaps only to the path of the URL. So you see a situation where we have a path or a location that takes in this URL. It could be a file inclusion vulnerability as well as an SSRF vulnerability, because we can use the path traversal technique to exploit this vulnerability. Now, some of these examples are easier to exploit than others, and this is where a lot of trial and error will be required to find a working payload. Now, if working with a blind SSRF, where no output is reflected back to you, you will need to use an external HTTP login tool to monitor requests such as requestbin.com, your own HTTP server, or Bob Suite collaborator clients. Let's answer the question below. So we have answered the question where what websites can be used to catch HTTP requests from a server. We just mentioned that, and that is requestbin.com. I'm just going to make it easy, copy that, and let's paste that here and hit submit. Correct. So we're done with task 3. Let's quickly hop on to task 4. Defeating common SSRF defenses. Now, more security savvy developers aware of the risks of SSRF vulnerabilities may implement checks in their application to make sure the requested resource meets specific rules. Now, there are usually 2 approaches to this, either a deny list or an allow list. What is a deny list? A deny list is where all requests are accepted apart from resources specified in a list or matching a particular pattern. Now, a web application may employ a deny list to protect sensitive endpoints, IP addresses, or domains from being accessed by the public while still allowing access to other locations. Now, a specific endpoint to restrict access is the local host, which may contain server performance data or further sensitive information. So, domain names such as localhost 127.0.0.0.1 would appear in a deny list. Now, attackers can bypass any deny list by using alternative localhost references such as 0.0.0.0.0.000, 127.1, and so on, and including even 0.177.0.0.0.0.0.0.0.1, or subdomains that have a DNS record which resolves to the IP address 127.0.0.1, such as 127.0.0.1.nip.io. Now, also in a cloud environment, it would be beneficial to block access to IP address 169.254.169.254, which contains metadata for the deployed cloud server, including possible sensitive information. Now, an attacker can bypass this by requesting a subdomain on their own domain with a DNS record that points to the IP address 169.254.169.254. Allow list. An allow list is like the opposite of the deny list. It is where all requests get denied unless they appear on a list or match a particular pattern, such as a rule that an URL used in a parameter must begin with https website.thm. Now, an attacker could quickly circumvent this rule by creating a subdomain on an attacker's domain name, such as the https website.thm .attackers-domain.thm. Now, the application logic would now allow this input and let an attacker control the internal HTTPS request. Okay. Open redirect. Now, if the above bypasses do not work, there is one more trick up the attacker's sleeve: the open redirect. An open redirect is an endpoint on the server where the website visitor gets automatically redirected to another website address. Now, take for example the link https website.thm/link URL equals to https://tryhackme.com. Now, this endpoint was created to record the number of times visitors have clicked on this link for advertising marketing purposes. Now, but imagine there was a potential SSRF vulnerability with stringent rules which only allowed URLs beginning with the https website.thm. Now, an attacker could utilize the above feature to redirect the internal HTTP request to a domain of the attacker's choice. Now, let's answer some questions. What method can be used to bypass strict rules? So, a situation whereby we are unable to bypass the allow list or the deny list, we can use the open redirect. Hit enter. That's correct. What IP address may contain sensitive data in a cloud environment? We're looking at 169.254, again 169.254. Submit. What type of list is used to permit only certain input? That is allow list. Okay, allow list, hit enter. And what type of list is used to stop certain input? So it's the opposite, which is the deny list. Okay, and that answers the question for the last question for tax 4. Lastly, tax 5, SSRF practical. So let's do some server-side request forgery practical. I'm going to quickly start this machine because I know we'll need that. Now let's put what we've learned about SSRF to the text in a fictional scenario. Now, we've come across 2 new endpoints doing a content discovery exercise against the ACME IT support website. Now, the first one is /private, which gives us an error message explaining that the content cannot be viewed from our IP address. So it was blocked. Probably they are using a deny list. Okay, now the second is a new version of the customer accounts page at customer new accounts page with a new feature allowing customers to choose an avatar for their account. Okay, that's it. Now begin by clicking the start machine button. We've done that. It's currently 14 seconds. Now to launch the ACME IT support website, once running, visit it at the URL, which is going to be ready in 4, 3, 2, 1, go. Okay, so it's ready. I'm just going to open that quickly and then follow the below instructions to get the flag. Let's start. First, create a customer account and sign in. Once you've signed in, you're going to visit this link here to view the new avatar selection feature. By viewing the page source of that avatar form, you will see the avatar form field value contains the path to the image, more like the location. The background image style can confirm this in the above div element as per the screenshot below. So let's get working. Let me increase this a little bit. Click on customer and we're going to sign up here. Click on sign up. Username, I'll just use hacker. And on the email, I'm just going to use hacker@gmail.com. And password, I'm going to use just the 6 same letters here, 6 same letters, and hit sign up. And there we go. We've created an account. And it says we should open this link once we're done creating an account to view the new avatar selection feature. And there we go. As you can see, we can view the avatar selection pictures here. Now, to view the source page so we can see, Control U, increase that a little bit, scroll down to the bottom part, you would see the avatar images, and we can see that it has the path or the location where this image is stored at, access /avatars/1, 2, 3, 4, 5, 6, and so on and so forth. Okay, now let's see what we need to do next. Now, if you choose one of the avatars and then click the update avatar button, you will see the form change, and above it display your current selected avatar. We're going to do that soon. And then viewing the page source will show your current avatar is displayed using the data URL scheme. So the data URL scheme, and the image content is base64 encoded as per the screenshot below. So we're going to be making use of image content here. And now let's try making the request again, or let's quickly just do that first. Okay, so I'll just select the first avatar here, click on update avatar. Okay, and Control U on this. If I scroll down, let me increase a little bit. If I scroll down a little bit now, we can see here the avatar that is selected here, background image, and as you can see, the image URL here has a base64 for the image content here. Very long. Okay, I'm going to close all this. Okay, now let's head on to continue. Now let's try making the request again, but changing the avatar value to private in hopes that the server will access the resource and get past the IP address block. Now to do this, firstly, right click on one of the radio buttons on the avatar form and select inspect. Once we've done that, we're going to edit the value of the radio button to private, and let's quickly do that. So I'm going to scroll down. I'm going to use the second one here, the second avatar here. I'm going to click on inspect, and it did pull up our inspect page. Could pull up a little bit. Let me do that again. Click on this, click on inspect. Okay, there we go. So that's the radio point here. So let me zoom in a little bit. If you can see, we have the value here as set avatar 2. I'll click on that, and I'll delete that, and I'm going to insert /private. Let's see if it's going to give us information about that. So I've edited that. Now I'm going to select the avatar number 2, which we just edited. Put this a little bit downward, click on update avatar, and let's see what happens. It says URL cannot start with /private. Let's continue and see what we need to do. Now be sure to select the avatar you edited and then click update avatar button. Unfortunately, it looks like the web application has a deny list in place and has blocked access to the /private endpoint. Okay, now you see that's the error message. Now as you can see from the error message, the path cannot start with /private, but don't worry, we still got a trick up our sleeve to bypass this rule. We can use a directory traversal trick to reach our desired endpoint. Now try setting the avatar value to x or x/./private. Okay, let's try that now. I'm still going to go back to that same number 2 we used. Click on inspect. It brought us back to this point. Let me increase this a little bit, and I'm going to double tap on that part here, delete that, and I'm going to use x/./, and I'm going to type in private. Once we've done that, I'm going to hit enter. It has done that for me. I'm going to slide this down a little bit, and I'm going to select the avatar number 2, scroll down a little bit, click on update avatar, and as you can see, it was successful. We just updated an avatar from the private directory. Now you will see we have now bypassed the rule, and the user updated the avatar. Now this trick works because when the web server receives the request for x/./private, it knows that the / string means to move up a directory that now translates the request to just /private. Viewing the page source of the avatar form, you will see the current set avatar now contains the content from the /private directory in base64 encoding. Decode this content and it will reveal a flag that you can enter below. Okay, we'll close here the inspector 2. Still on this page, click on Ctrl U. It takes me to the source page. I'm going to scroll down a little bit, scroll down, and we can see the avatar that was uploaded and the image URL here with base 64. So I'm just going to copy this code. Remember to include the equal to sign, for which is a padding option. Copy Ctrl C. I'm going to go to a new website here called base64decode.org. Click on enter. It takes me to this website where we can decode a base 64 information. Paste that information there, the format. Click on decode. It has decoded it for us, and as you can see, we have our flag, THM, Tryhackme. You worked out the SSRF. I'm going to come back to our main page here, Ctrl V, submit, and that brings us to the end of the room, Intro to SSRF. I'm happy to have studied this room. Thank you for studying and learning with me. I'll see you guys in the next room on cross-site scripting, and do enjoy the rest of your day. Ciao.